Okay, so now we would like to talk about the temperature, which is important aspect of the Maya fluids container details. So think of the fact that you have the piece of the wood with you and you would like to ignite that. So the piece of the wood will going to act as the density for the reaction, and once the temperature is beyond the ignition temperature simply means that the minimum temperature required to achieve the state of the reactions. So the temperature above the ignition temperature will let the density to get start burning. All right, and the responsibility of the temperature is also to rise the fluid in the upward directions. Even the smoke, they do have got their own temperature due to which they rise high. Okay, now let's just go further and take a look at the definitions what we have. The temperature helps in rising of fluids and also ignites the fuel to burn quickly. For sure, definitely. The reactions of fire and explosions are achieved with temperature. So, the common thing is that, if you would like to create an effect of the fire inside Maya, you need to utilize the term called as a temperature. Not only from the look and feel point of view, but also from the shading point of view, because the temperature field is also going to link up with the incandescence attribute of the fluid container, which simply means that the self-illuminating property of the substance. So if we like to go inside the surface property, so it means that the incandescence object, which simply a fire or explosion, they do have got their own shading, which is also based upon the black body. Now the black body is a term we use which differentiate or which categorize the distribution of the color based upon the temperature. So here the utilization of the temperature is extremely important in achieving the look and feel of the black body. Okay, and as we have already mentioned that the temperature is very useful while linking temperature with incandescent attribute. Alright, so let's go ahead with more attribute of the temperature. So we have got the temperature scale and the diffusion. So temperature scale being the universal multiplier for all the attributes underneath, and the diffusion here again would like to describe that the how quickly the voxel would get spread out inside the container is the job of the diffusions. And here the word diffusion, the attribute diffusion is the only attribute which would help you in achieving the look and feel of the black body. All right, so the distribution of the temperature with respect to a kind of a gradient is very essential in achieving a look and feel of the explosions. So when I gonna teach you the explosion, I would definitely be taking care of this term diffusions. All right, now we have got the buoyancy and the pressure. So the buoyancy is simply like that, it helps us in the rising of the fluids. The positive value will going to take the fluids further high, that going to define that the temperature is pretty high, and the lower value will going to make the fluids move into the bottom section. So the example is the dry ice. And again we have the pressure, which is similar, you may could interpret it with the density as well. So the pressure would try to outward, or you may could say it expands the voxels. Okay, and we have the dissipations and tensions. Then again, the dissipation is the naturalistic behavior of the fluid in which it diminishes or vanish itself with respect to the time. So if we have the higher values of the dissipations, the temperature will tend to get cool off quickly. We have lower values of the dissipation, simply means that the temperature would take further more time to get itself to the state of the cool, or you may could say that it will take more time to get itself to get diminished, or you may could say settle down, or it will going to reach the state where it is almost cool off. So next we have the tension. It simply means that again a property of the surface tension which is useful in the liquid, but we can also utilize the tension inside the temperature. It will going to create the effect of the stretchiness in terms of the shading. And I also would like to show you this particular attribute is clearly visible in our explosions which we're going to create inside the Maya. And we have the noise and the turbulence, which these two are pretty confusing things, and they both sound similar. Noise and turbulence both means disturbance. So I'd like to talk about first on the noise. Noise is the property of the temperature voxels, which will going to bring the randomizations inside the temperature voxel values, whereas the turbulence is the property which is indirectly linked to the velocities inside the fluids. That means if inside the temperature fields you have higher turbulence, it means that the velocity will going to be pretty much high, or you may could say the reaction would become a little bit not unstable, but it would be very aggressive. So that kind of thing you could able to achieve with the help of the turbulence. Okay, so that's all for now we have got for the temperature. I'm taking a pause in this clip and would like to move further to the next clip where we'll like to talk about the fuel attribute.